Hello everyone, uh, welcome to this channel and we have gone a lot of theory sessions in last couple of videos. Now let's shift our gears to hands-on session. In this session, I will demonstrate how to use Karpenter to dynamically provision EC2 instances and manage resources efficiently. So topics covered are I will show you, deploying NodePool, EC2 NodeClasses, and then running a simple uh, application workload. And we will observe how Carpenter scales the node. And then we'll go through the logs. We'll also go through all the configuration and understand the purpose of each configuration options. And then, we will see at last the logs and we will revisit some of the concepts, what we learned during theory sessions. All right, so the prerequisite are we need to have a EKS cluster ready so that we can, deploy our Carpenter and, we should have all the IAM roles and Carpenter set up properly. Now, I'll show you what I'm using to achieve all that. And it's going to be pretty simple. You can also use that, but that is just for, demo purpose. When you're doing actual creation of your cluster and deploying a Carpenter, you should, use either Terraform or, CloudFormation, whatever, automation you're using in your uh, project. All right, so let's go to the editor. Okay, so I have a sample deployment here and then the EC2 node class and node pool. Now, for Carpenter, there are 3 custom resources which gets deployed and which we will see that. And before that, let me show you how I deployed and created the cluster. So what I'm using is I'm using this tool called EKS demo, which is in-house tool developed by AWS. And the whole idea is how to create these clusters for demo purpose, quick and fast, rather than you use some tool to create the cluster and then all the required deployments, everything you can create through EKS demo. Now, they have clearly mentioned here that this is only for demo kind of workload. So if you see here, they say that you use this tool to create EKS cluster for learning and testing and demoing EKS as what I'm doing now. The advantage of this is kubectl like CLI, which is very easy to manage and quickly show some of the details related to cluster and nodes, and very quick to get up and running. Now, I have just ran 2 commands to create the cluster and install Carpenter. To create the cluster, it's just simple EKS. Let me show you. Yep, so this is one command which I run to create the cluster, EKS demo, create cluster, give the cluster name, and then you need to uh, provide what type of instance you want to create uh, as a part of your workload. Then you set the min and max, and then what is the desired number of nodes. Now, once the cluster is created, then next step is you need to install the Karpenter. Now, to install the Karpenter, again, it's a very simple. You see here, EKS demo install Karpenter is just gonna pull the uh, Helm chart uh, for Karpenter, whatever is the latest version. And it's just gonna deploy it on your cluster. That's it. So it took for me, less than 30 minutes to get the cluster up and running and have Karpenter installed and ready for testing. And when it installs the Karpenter, it also creates you a sample EC2 node classes and node pools so that you can just deploy some simple application and test the Karpenter. Okay, so this is on the deploying your Karpenter and creation of uh, EKS cluster. Pretty simple and straightforward. All right, so next, let's go to the resources which we are going to deploy. One is the node pool, which is the custom resource for the Karpenter, and basically that defines the constraints and configuration for the nodes which will be created by Karpenter. And then it allows you to specify a lot of parameters, which we will go through. We are going to deploy that. And then next one, which is one of the important ones, this is called EC2 node class. That is one other custom resource definition created by Karpenter. Now, this configuration basically for provisioning Amazon EC2 instances within the cluster. It allows users to define parameters such as AMIs, subnets, storage configuration, mainly specific to cloud provider. So in this case, yours is AWS, we are using AWS and we're creating EC2 instances. It's very much specific to that provider. And then I'm deploying a simple NGINX app. So before we go in detail, I'm just going to show you CRDs. So you can see here, EC2 node class, node pools, and node claims. Now, if you have seen my theory classes, you have hopefully you have understood what is node pool, node classes, and node claims. But we'll just go through on these concepts briefly in this session. So we go back here and let's go to the node pools. So as we understood, these are basically constraints and configuration for the nodes which Karpenter is going to create, and we'll just walk through the example configuration what I have created for NGINX. So if you see here, there are some standard details like labels and annotation, which is based on your specific requirement you can provide. Labels are important, based on these labels and the workload what you are going to deploy. You need to make sure that is matching. In case you want to make sure that your particular workload what you are deploying has to be deployed on a particular node. So you need to make sure that label is matching, and that can be done through the affinity or node selector in your deployment, which I will show you when I walk you through with sample deployment configuration. Next one is now this node pool, which has some of these constraint and configurations for your node. It needs to refer which node class it is going to use to create that EC2 instance. Now, as we understood that EC2 node class uh, has all the details required for us to create an EC2 instance, all the networking related AMI ID, the storage related data, all that is present in the EC2 node class. So node pool needs that reference. So you just need to provide the name of that node class. So if you see here, the name of the node class is NGINX node class, which I am referring here. Now coming to taints, these are uh, basically applied to the nodes to restrict, which pods can be scheduled on them. So only pods that tolerate this taint will be scheduled. Otherwise, it will not allow you to schedule the pods. So why we need this? Um, so like if you want to ensure that only workloads explicitly designed, in our case, NGINX application uh, with matching toleration, they are the only ones get scheduled on this node. Whatever the node pool is going to create, only the pods which meets that toleration, those are the only ones which are going to be scheduled. So let me just make sure I keep the deployment here so that I will show you. So if you see here in the deployment of a sample application, I have added the tolerations. Now this is to match the taints what we have defined in the node pool. Now toleration ensures that, again, the same thing, the only workloads are designed for this application needs to be scheduled on particular workload, which is created by our node pool. All right, so next, there are some concepts which we need to understand when we are going to use the node pool configuration. First one is expire after. It is, at a high level, here it is 720 hours. That is basically, this node can live for 30 days. Whatever time period you specify here, the nodes are replaced after that time. Now, there are many reasons for that. One is avoiding long running nodes. Uh, when it replaces, it will create with whatever AMI you specify, or it can, if you don't specify AMI, it will just go and fetch the latest AMI. That will help to reduce the security vulnerabilities, and then there might be some requirements from the organization side, where in some cases where your security agents, which are getting keep updated every now and then, so you need to adhere to those compliances. Then creating new nodes after X number of days will help you to get the latest agents or latest version of these agents. Specifically, we use it to make sure we get the latest AMI every time. We don't need to go and update our nodes. This will take care, after 30 days, whatever the latest AMI is available, it's gonna install or it's gonna use that AMI to create the new nodes. That is in case where you are using on-demand nodes. If you are using spot nodes, usually these spot nodes get terminated, uh, you know, a few times in a day. So that, will get the latest AMI whenever it's available. So we don't need to worry when you are using spot instances. But if you are hard coding your AMIs, then that's not going to help you, because whenever your nodes are created and even though it is spot, it's going to use whatever AMI ID you specify. So ideally, in case of non-prod environment, we just avoid giving the AMI so that it can fetch the latest AMI, and then that way we get the latest patches for all the vulnerabilities reported over a period of time. Okay, so the next option is termination grace period. The amount of time node can be draining before Karpenter forcibly cleans up the node. So sometimes, pods blocking eviction of the nodes because of pod disruption budgets, or if you have a custom, you know, uh, label, not label, annotation, do not disrupt. Basically, that will be respected for, in this case, for example, 48 hours. But post that, uh, it will be, forcibly, pods will be killed. So the purpose is to avoid, long uh, uh, running pods which are blocking the eviction due to PDBs or the do not disrupt tags annotations. So let's come to the requirements for nodes provisioned by this node pool. Now here, I have kept some of the configuration just to explain, which are commented here. But let me start with the ones which are not commented. Now here you can specify which node, sorry, which instance type you need for your workload. There are multiple ways you can do it here. You can just, don't specify this. Karpenter will intelligently take care based on your pod, CPU, and memory. It's just going to create whatever instance type it matches uh, for the requirement. And then it's going to make sure it's going to get the cheapest instance type with the, uh, you know, with the pool, with the maximum pool availability in case of spot instance. In case of on-demand instance, that is not required. The instances are not going to terminate it. But in case of spot instance, the instances will be terminated based on the AWS requirement. So Karpenter has some intelligence where it's going to fetch the spot instance type where it has enough pool capacity so that it's not going to be disrupted frequently. The next option is OS, and then the zone, the topology spread, which is important. Otherwise, if you don't give this, otherwise it's just can just create in one availability zone. So you need to take care of that. The next one is which architecture you want to create the nodes. x86, AMD 64, ARM 64. You can specify based on your requirement. And then the capacity type. Here I have specified spot and on demand. Now, the way it works is with this configuration, first it's going to try to get the spot instances. If whatever instance type I have defined here, if it doesn't find the pool availability for spot instance, it's just going to go for on demand. But mostly it does find the spot availability, but there are cases when it doesn't find it, it's just going to go and create the on demand. All right, so now coming to instance type, there are few options you can do. As I was saying, just don't specify anything. It's just Karpenter is going to create based on the pods, memory, CPU requirement. Or you can specify something like instance category, like you want to give the freedom to Karpenter to, identify the instance type, but you can say that you can create the instance in this category only, like compute instance, memory optimized instance, and then the moderate instance, the M series, C series, and R series. Uh, then you can go one step up where you can specify what instance family you want, like M5, M6, based on your requirement, R6, R7, R7A. You can specify based on your requirement. Some cases where you might have bought the savings plan and then you want to use only certain instance type, then you can just specify those instance type only. That way, it's not going to go for any other instance type, so that you can leverage whatever savings plan you have bought. Obviously, with on demand, you can leverage this kind of configuration. So there are there is a good amount of flexibility for you to choose the instance type, family, and then the instance category. And the documentation, if you see the documentation, let me just show you. So it has provided a lot of details which you can refer here and go through and understand some of the configurations mentioned in the YAML file. Back here. Next, the disruption policy for node replacement. This basically describes the way in which Karpenter can disrupt and replace your nodes. Basically, this is to reduce the cost. So Karpenter tries to reduce the cost based on the consolidation policy. Now, one of the consolidation policy is when empty or underutilized. So that means if your node is empty or it's not utilized and it has a lot of memory and CPU available. So then it will try to consolidate and try to reduce the instance type, or it'll try to remove that instance and then push the pods from that instance to another instance where the memory and CPU available. Here, time to wait before consolidating nodes after a pod change, like once it sees that, okay, this node is empty or this node is underutilized, we can provide the time before it, deletes or replaces node. So right now it is, I have set to 1 minute, but there are use cases where you can specify more than 1 minute, like 5 minutes, 10 minutes, based on your use cases. In case you're using like jobs, Kubernetes jobs, where those dynamically created, they will be running for a minute or so, and then it will be deleted, and then it will create, and again the jobs will be created after a few minutes. So in that case, you don't need to you know wait for Karpenter to create the nodes all the time. So you can just set the console rate after, a bit higher uh, number, like 10 minutes, 15 minutes, and then, it will use the available nodes. The budgets basically control the speed at which the Carpenter can scale down your nodes. Like, we don't want to, in case of consolidation, we don't want to scale down the nodes, drastically. Like, suppose you have 10 nodes and then you don't want to, consolidate like all the nodes at once. So Carpenter provides an option to limit the node disruption. By default, it is 10%, but you can control that option based on your requirement. Now, this is a very important one where you can limit the total node pool size. What does that mean? Basically, it lets you set limits on CPU and memory that can be used uh, by this node pool on the cluster. So if the instance is created by this node pool goes above 64 CPU and 256 gigabyte, then it's gonna stop creating any further nodes. So this is kind of a guardrail for your node pool. So you can decide, based on your workload, what is the uh, value for CPU and memory limits. Then this is the last one, wait for node pool prioritization in scheduling. Now, the idea here is that when you're using the node pool for different stacks, like you have dev stack, you have stage stack, call stack, test stack, so you might create multiple node pools, and then also you might create node pools based on, you might have bought the savings plan, and then you want to make sure you consume those node types first. So you can create a node pool with the weight 1. And then once you are out of your capacity, which you can define based on your limits, once you have created, all the nodes for your savings plan, and then the next, whenever the new pod comes up, you are already hitting the limits, then the next node pool will be evaluated, which has weight 2, weight 3. That is the main idea here, where you can use it for node pool prioritization. All right, so this is the node pool configuration. We'll just quickly walk through EC2 node class. Now, we know that this is very much specific to related to your cloud and EC2 instance configurations. Here you will define what type of AMI family, L2, L3, then the AMI selector terms. As I was telling you, you don't need to specify the AMI, but cases where in production, you might want to control what AMI gets deployed, then you can specify the AMI ID here. Otherwise, you can just, avoid putting any value here, and then Karpenter will always gets the latest EKS optimized AMI for your cluster version. Then you have to provide a few details on the subnet and the security group for your nodes. And then this is the IAM role which will be associated with the nodes. So you need to make sure you have the necessary permissions for that. When you use tool like EKS demo, it will just create all the required role with the required permissions for you. So you don't need to worry about that. You can just pick the right IAM role, what it has created for you. Then if you need to attach some volumes to your EC2 instances, whenever you're creating those instances through Karpenter, you can add those volumes with this configuration. And then these are instance metadata configuration, which says that, okay, you have to use the HTTP tokens for your metadata surveys and then set some hop limit. Basically, it controls the hops that you can see here. The idea here is the AWS suggests that you set this number so that you can mitigate certain types of network-based attacks, and based on the uh, value provided by AWS documentation, I have just updated this number here. Okay, so this is the EC2 node class. Now, just walk through the deployment. It's just a simple nginx deployment. I have set the tolerations as we discussed, and then I have set the affinity with the topology spread, and then the which architecture I want, and then the label, just to make sure the right nodes gets the uh, nginx ports. All right, and then I have defined resource and request limit, which is an important aspect for your workload whenever you are using Karpenter, because Karpenter does all its decisions based on the memory and CPU limits. Now, we discussed about NodePool custom resource. We discussed about EC2 node class custom resource. The last one is the NodeClaim custom resource. So basically, NodeClaims is going to, once it sees the pod getting into pending state, it's going to check for the CPU and memory requirement, and then it's going to look for which node pool matches the requirement. And then once it sees that particular node pool matches the requirement, it's going to create that node claim. And then once it creates the node claim, the Karpenter is going to use that node claim to create the cloud resource, in this case, AWS EC2 instance. And then once this instance is created, once it is registered, uh, then it will be available for our pods. Okay, so let's see, we'll deploy this resources, and we will see how Karpenter creates the nodes, and how much time it takes, and then we'll go through some of their logs. Let's go here. So you can see here, I have 4 terminals here, the pods. Here I'm showing you the nodes, and then the Karpenter logs, and here NodeClaims. Now, when I created the cluster, using EKS demo, it created one instance where it has scheduled all the required core components, and then also installed the Karpenter. Go here. So I don't have any NodePools or EC2 node classes deployed on the cluster. So now I'm going to just deploy the application. Now you should see that all pods goes to pending because there are no matching, node pools or configurations present on the cluster. Plus, it's not going to go and schedule on the existing node here, whatever you are seeing here, because this deployment has the affinity where it's going to get scheduled only on particular node with the particular label. Let me apply this. It's applied. This all going to go to pending state. And you can see here no node pools found. that's the expected error in this case. Now go and apply the node pool and EC2 node class. So first I'm going to apply EC2 node class. And here we go. Let's check the. All right, everything's applied now. You should see Karpenter should, right? Okay, so you see here it's created the node claim. It says that D3 medium is the instance which it is going to create based on my configuration, what I have provided, and then the spot instance which will be launched for this requirement. So it analyzed the requirement for nginx application, and then it created the node claim. And once it created the node claim, it launched the instances, basically sending an API call to EC2 fleet APIs, and then it's going to create the instance. So you can see here the new instance getting created, and you will see, the instance get ready very quickly. So you can see here it's 15 seconds. So within 15 seconds, the node is ready. Then the pods are started, and then they are running. So it's that fast. So as suppose you are using any cluster autoscaler or EKS managed node group, it's going to take good amount of time for nodes to create and register with the API server and be available to take the workload. The Karpenter is way too faster. So I just captured the logs. So I'm going to just show you, when the workload is created. So you can see the way the message is displayed in the logs. Found provisionable pods, and then next step it does is computes the node claim. As you saw, the node claim got created, and it computed what type of instance it is going to launch. And that is where you will see here created a node claim, and it finalizes this is the instance type it is going to use. Then there are three phases of node claim: launched node claim, where it is basically going to uh, work with the cloud provider and create the EC2 instance. Then once the instance is created, it registers that instance with the node claim, and then updates required tags, whatever you have specified in your node pool. And then once it is registered and available, the status is initialized node claim, where now the instance is ready to schedule the pods. So this is what happens when when you deploy a workload, and then behind the scenes, node claim does all the magic for you, understands what instance type it has to create, and then it creates that instance type, make sure it updates all the required annotations and tags, and makes it available for our workload. All right. So now let's just delete our workload and delete the deployment, and you will see what happens. How does Carpenter behaves, and how does it deletes the node. And then let's so as soon as we delete, the deployment. Now you have seen there is a configuration which I showed you how many minutes Karpenter can wait before it consolidates the node. So I have set it for 1 minute. Once it once it is completed the 1 minute cycle, then Karpenter is going to delete that node. So this is the configuration which I was referring. Consolidate after 1 minute. Now, the reason it is going to consolidate that node is because it's empty. There are no workload is scheduled. Let's wait and see the logs here. Okay, and I have captured the logs for you to show what happens when it starts deleting the workload. Okay. You can see here it updated the taint on the node that carpenter.sh disrupted, and then it has set that no schedule, so no pods will be scheduled, and then it will be terminated. So let's go to the logs one. So when the workload deletion starts, okay, it's you can see here it has started, and then this is port instance, so it should delete any minute now. All right. So from the logs, the first message you will see is disrupting node claim via delete. Now, what would be the reason for that? You can see the reason here empty because there are no workloads on that node. So the reason sets as empty. Karpenter sees that there is no workload on that, and then it sets the reason as empty. And then you can see here it, as I showed you, that it annotated the node claim. Then once that is done, you can see here tainted node carpenter.sh disrupted. Yeah, this is the one which I was trying to show. So after the annotation, after updating the annotation, it taints the node, and then once it is done, it is going to delete that node. Once the node is deleted, it will also delete the node claim. So if you go here, there is no node claim here. Yeah. All right. So I think this is all what I wanted to show you guys today, going through the configurations, deploying the node pool, and EC2 node class and a sample application, and showing you how node claim plays a big role here, and tries to schedule the workload based on the exact requirement for your workload. Now, my plan is that once I upload these tutorials, this is mainly I covered the basics of Karpenter. We are running Karpenter in production like more than a year now, and the next set of tutorials will be more on the advanced concepts where how do you optimize Karpenter for your production workloads, like basically how do you balance spot and on demand instances for cost management and some of the best practices for that. How do you ensure fault tolerance and high availability, like methods to distribute workloads across multiple availability zones using topology constraints, and then implement pod disruption budgets to maintain your application availability during scaling events. So how do you do that in production environment? And customize scheduling where you use node affinity toleration combination of both. How do you uh, do that? And I will also discuss about the advanced scaling policies, budgeting, uh, how can you do scale to zero. Yeah, so then monitoring metrics. Uh, I'll try to cover all those details with some demos in upcoming video tutorials. Okay, all right, guys. I hope you liked this tutorial series, and if you have any questions uh, or feedback, provide me in comments, and I'll try to get back to you as early as possible. Okay. Until next time, uh, happy learning, guys. Bye bye.